Again, thanks for joining us. Hope everybody's doing well out there. I know that us as regional managers for Lakos, we're ready to get back out in the field and get our hands dirty with you guys. Being locked down out here in California, I'm not sure what states everybody's from that's out there, but hopefully you guys have a little more freedom than what we do. So with that being said, we're going to avoid doing a PowerPoint today. I don't know how many of these things you guys attend on a regular basis, but us that give them, PowerPoint gets a little bit old. So we're going to use our website as the basis, and it'll kind of give you a little bit better feel for the website and how to use it and where to get certain resources to as we're going through it. So with that being said, let's get digging in here. We're going to be talking about specific products and how they apply to either a solid that floats or a solid that sinks. And for those of you that are familiar with the Lakos product, in the past, most of the time we're focused on the solids that settle, and that's when we use the centrifugal separator for that. The floating debris, on the other hand, tends to come into play with a lot of applications. And for those of you that may or may not know, we do have other product lines that help remove those floating solids or finer solids than what the separator can actually remove. So we're going to go through some of those today too. And we'll start with the floating debris and what type of products do we have for that. So a good rule of thumb, again, for those of you that have been around, is you can take a clear, get the camera right here, you can take a water bottle, a mason jar, put your solids in it that you're looking to remove, and then shake it up really well, and then just sit it down just on a surface and let it sit for 2 to 3 minutes. And whatever's on the bottom of that jar or the water bottle, typically the separator is going to be able to remove for you. Anything that's above it, or if it's cloudy or it's still floating on the top, then that's when we need to go to some sort of alternative filtration device to get that material out. So with that being said, we'll jump kind of into, on the products, you can just roll over the product line, and then you can come over to industrial. As you can see, we have, there's 3 others, the HVAC, irrigation, and municipal. But in the case of what you guys are dealing with, these are the products that our industrial reps specifically focus on. So we're going to go ahead and we're going to start with the self-cleaning screens. I'm not sure if you guys were on Eric's presentation. I think he did it last week regarding the screen filters. But this is a good device when we're looking to remove things that are smaller than, let's say, 44 to 74 microns. And whether they sink or float doesn't really matter. We can potentially pre-filter these also with a separator. But as a whole, what you're dealing with is a barrier filter that starts off clean. It builds up a differential from 0 to 10 roughly with this particular product. And then once it hits that 10 pounds differential, it'll kick into what we call a flush or a wash cycle. It'll clean the screen off, the water and the solids go to drain or to tank or wherever they're dumping them to. And then it goes back into a full, what I call online mode. So if you can see here, the flow rates are 15 to 7,300 GPM. And those will vary based on, which is really important, is your suspended solids. So that's real critical when it comes to these screen filters, because the finer you go, let's say you start off with a 100 micron screen and then decide, well, let's go to 50. And then if 50 is working pretty well, let's go to 20. Once you start getting into the 50, the 40, the 20, the 10, the 5, they blind off really quickly with higher ppm. So if we can, we want to get a water analysis for the suspended solids percentage. And that'll help us focus on how to size and what we're going to do with them. So some of the applications that you guys may run into, process cooling, industrial, there's some municipal. I know that some of you industrial guys kind of call on the municipal markets too, that we've seen them for the municipal well water. Irrigation, if you happen to run into any of that. But process cooling and just general industrial process is where you're going to probably fall. There certainly are variations of the filters themselves, which we can open up real quick. Increase this row a little bit. And with the screen filter itself, just the operating principle, water comes in. There's a coarse pre-strainer on some of them, on the heavy-duty versions. We call them, it's the 2-stage. So this is anywhere from, I think it's 3/16, 8 3/16, quarter inch. And then this is the fine screen, and this is the wand that will draw the material off once it goes into a backwash cycle. And then this is the out. So it's a fairly straightforward device. There's an indicator on the end of this to show the position of the wand. So if we go, you can see this is dirty. And then once you open this valve to atmosphere, it'll initiate this cycle for this to pull backwards. and to draw that material off the screen. And once it goes through that cycle, it'll go right back to the original position, and your DP should go back to nearly 0 to 1 pound differential. If you notice that that differential is not coming down, then it's possible that screen has embedded material in it. The finer the screen you go, the more surface area we're going to require, just because you don't want that blinding off immediately. So there is some sizing criteria, which you'll see a little chart here, and it's flow area, and it's gallon per minute per square inch. So if you know your screen overall square inch, these are the percentages that you reduce it based on your micron sizing, and then also based on how dirty your water is. So that's where your ppm is really critical. So at any rate, so that's one of the products for, again, for finer than your, call it 44 to 74, and anything that floats or that separator cannot remove. So we'll go back to here. We'll go back to products. The next one we're going to go through is the industrial screen filters. Some of you may or may not be familiar with this, but these are self-cleaning intake screens. These are submerged underwater. So the screen rotates around, I'll call it, there's a drive wand up in the top, and it rotates that screen, and then it has multiple nozzles to keep that screen flushed off. This would connect where the flange is to the bottom of your pump intake, which is coming into, let's say, a canal, a pond, maybe it's a river water or a lake of sorts. And then that drops in, and you run a small amount of water back from the pump discharge to these nozzles to keep it driven. And as it rotates again, it pushes all the material off that could potentially get up into your pump. So again, we do have the submersible separators that go down into wells, but that's all they are for, is going down into wells. So this is a nice device that you can put onto that pump intake, and the flow range is anywhere from about 300 roughly up to 2,700. So if you have multiple screens together, we can certainly get higher flow rates than what you see as a maximum. So just inquire with your regional manager if you guys happen to have an application. And you can see that on all the products that are listed here, I'll just go back to it real quick. There is a bar that's right below the first page, I'll call it. And you can go into options, which in this case there isn't. You can download literature. There's a manual form, and any accessories if there happen to be, which I'll show you in a different product line, and then any other downloads that are associated with it too. So that bar is live. It's not just words. So you can click on those to get those other things. All right, again, we're talking about the products that will be used for material that floats, that does not settle, and stuff that's smaller than your 44 to 74 microns. So next we're going to go into, we're going to cheat a little bit here. So under HVAC filtration, we do have what's called a carbon steel sand media filter. And these typically are going to apply, I'm guessing, with your process cooling towers that are on whatever sites or facilities you might be calling on. So these vary in size. Again, the range, here's that bar again with all your associated stuff. The sizes range anywhere from 54-inch diameter up to 96-inch diameter, and that's the physical size of the sand media filter. And for those of you that aren't familiar with sand media filters, they are exactly what it sounds like. So you can see that there's a particular type of sand in the bottom, and there's another, we call it a Media Gem 85 or 475, and that's just the structure of the sand itself. And sand does the filtration. It comes into the top, it gets dispersed across the top of your sand media bed, and it's kind of like a mountain. That water comes through that sand media, and it removes that material down to about 5 microns, and then your outlet goes back to your process. So like I said, these are really good for helping clarify water, or if they have a high turbidity. We can't guarantee it's going to get to X turbidity, but we do know that sand media does well at clarifying, especially if you have a lot of iron oxide in your water, or a lot of pollens, or really fine stuff, or stuff that floats that again, that separator cannot get. They do take up a fair bit of space, so you want to make sure wherever you're potentially going to install them has room for them. And the backwash cycle, so let's say, for example, 1,000 GPM sand filter, it's a 96-inch diameter, so it's the tank itself is fairly large. It's going to backwash about 700 to 800 gallons a minute for 3 minutes every time it goes into a backwash. So if you think about that, that's anywhere between 2,100 to almost 3,000 gallons of water that gets dumped to flush this tank of all the debris that it's removed. So if you guys decide that you want to look at sand media for some process cooling of sorts, or if an owner is really dead set on having that, just make sure that you take into consideration some of the things that are, I'll call kind of a nuance when you're used to selling separators that just operate on their own. The other thing I'll point out is if you look, they're a pneumatic actuated valve. And so we also have an option for electric. So we just need to make sure they have air on site to operate the standard equipment. All right. So we'll go back to our products. So the next one I'm going to talk about is bag filters. And the bag filters, again, we don't promote them too heavily, but we do have a manufactured bag filter that we do in-house. And it's buried in with the separators. When I get there, I'll show you where it's at, but I have it loaded already here. Again, we call it a bag filter housing. It's pretty straightforward, a BFH. And it has 3 8-inch by 33-inch bags in it. So it has pretty decent capacity. The flow rates can go up to 450 GPM. And again, that's somewhat based on how fine a filtration you want to go. And it's like the screen filter, that the finer the bag you use, the more difficult it is to get water through it, number one. And number two, it'll blind off quicker. So your differential across your inlet and outlet as it collects material increases very rapidly. So the lower flow you go, the longer those bags are going to last. And the larger micron you use, the longer it's going to last also. So we got to do a little digging with your customer that you're talking with if they're looking or interested in using the bag filters themselves. So the other option we have is you can do a 3 or 4-inch inlet and outlet on those. So that's the bag filter. And so in terms of anything else that we have that is for that floating material or material that's finer than, let's say, your 44 microns, which is where E-series separator goes, that's really it in the world that you guys live in. There's a lot of heavy industrial that you call on that just bags and cartridges of the like are difficult to install. So we really focused on separators in those markets. But if you run across something, don't be afraid to ask your regional manager to help you out, or see if we have something that can help with either the really fine stuff or the stuff that's floating that's also in that water. All right. So with that being said, we'll jump on to material that settles. And again, anything, I don't have my little camera thing on my screen. So if you can see this, it's whatever settled in the bottom of that water bottle within 2 to 3 minutes is what we're going to target with a centrifugal separator. So we'll start with an EJPX, which is our high efficiency centrifugal separator. They've been around for probably 3 years, I'm guessing. And for those of you that don't know, I've been with Lakos 23 years. So I've been with them a long time. So I'm pretty familiar with the products, how they work and what they do. But I can't remember when we introduced this. So it goes to show the gray hair, right? So the EJPX separators, and I'll point out the differences between the two, because a lot of people get confused. Why would I use an EJPX separator over our standard JPX separator? And the key is in the efficiency. These are proven out and tested 44 microns at 2.6 specific gravity. And most of you probably know, but specific gravity is just the weight of the material that we're trying to pull out. And water is the constant at 1. And so if you see 2.6, that material, in this case, let's say it's sand, is 2.6 times heavier than water. So the heavier the material, obviously, the better we can do at removing it. So we really start out at about 1.8 specific gravity, I think, on our efficiency charts. And then we go up as high as whatever it could be. It could be lead, it could be gold, it could be copper. I know if any of the semi-tour guys are online, they do a lot in the copper mines in my territory out in Arizona. Copper comes out very easily, obviously, because it's a heavy metal. So that makes a big difference. The other thing I wanted to point out is, in terms of advantages with this particular separator over the older style JPX, is I'm not going to play the video, but we have a smart purge. And so again, we're going to use the accessories. And Steve Geisel may have gone over some of this with his industrial rep. So if any of you guys are on here, I apologize if this is kind of a repeat. But the smart purge system is a vibratory probe that goes down into the bottom of the separator. That way you're not purging by guessing. this probe, as the solids build up in the bottom, this probe, it'll change the frequency it runs on. It'll trigger a solenoid, and it'll open up the purge valves, which it could be any of these. It'll send the signal. It'll open for X amount of time, whatever we have that set for, dump your material, and then close back up. So it's a nice device that we've introduced to not guess on how frequent we have to purge the separators. So I just want to make sure and point that out. That is one difference with the JPX, also with the eJPX. All right, next, for those of you that have a lot of, I'll call it food industry, or where they're processing a lot of frozen foods or chips, French fries, potatoes, I think the bulk of it is out west here. We do a lot just because they grow a lot of potatoes in the Pacific Northwest. But for those of you that have hot cooking oil, or that you call on plants for that, the CSX separator is a device that we've developed specifically for hot cooking oil. So some of you may have seen it. They're built in carbon steel or stainless steel. We can flow anywhere from 50 up to 3,100 GPM in these particular units. And they're designed to have access to the bottom in case something gets plugged or clogged. Obviously, they have an accessible top, so we can get into the slots if something were to plug them. And then it has gauge taps, because oil, the specific gravity of oil when it's being used or hot, the viscosity of it is a lot thinner, obviously, as it heats up. But the specific gravity is like 0.81, if I recall. So we're able to remove food particulate in this particular application, whereas if we're running water, we may not. It may float in the water versus settle. So as your fluid density changes, then we can adjust on what we could potentially remove in it too. And again, that settling test will help you out when you're doing that. So there's various accessories and options with the CSX models. We do create a fry safe, which I'll just click on it real quick. Which you can see what that is the CSX separator, and then it has alternating, there a stainless steel basket that's in there, and I think we have them set at 100 microns, if I recall. And that's where we remove the crumbs and can collect the crumbs. The difficult part is if you have a really high concentration of breaded product, or products that build or drop a lot of stuff into the oil, these can fill up fairly quickly. So we need to do some research on what the application is going to be before we actually say, hey, look, this is going to work properly. But we do build complete automated systems with this also. All right, so we'll jump into the actual JPX. So again, the major difference with these compared to the eJPX is, again, flow ranges will vary. The eJPX, I think we go up to about 1,500 gallons a minute. With these, we have the full range of 4 all the way up to 12,000 gallons a minute through a single unit. The major difference is your efficiency again. These are targeted at 74 micron, 2.6 specific gravity at 98% removal. They work very well, as they're proven for all these years. I think we introduced these roughly in 2000, so they've been out on the market for about 20 years now. They make great pre-filters to your bag filters, to your cartridges, any of the processes you're doing. Machine coolant, we don't do too much, but if any of you are out there with the machining centers and they want to remove metal fines from coolant, we can certainly look at that. And then again, your accessories and options for this are going to be very similar to the eJPX, but you notice the Smart Purge, it's not on here. On the bottom of these separators, we do not have the port that you thread in that vibratory probe into. So these are just purging with the automated ball valve, pneumatic ball valve, or this is an air-operated pinch valve, which the bulk of the processes you guys do probably are going to require the pinch valve, just because it operates better with a high solids loading. It doesn't wear out as quickly as what maybe a ball or the seats in that 3-piece ball valve will wear out. And again, just basic bag filter options that we can purge the solids into. And then again, what I showed you earlier, the bag filter that you can actually use in the process. These are more of just solids handling bag filters. They're not actual process bag filters. So the other thing I'll point out with the difference between the JPX and JPL, and then let's just open one up here. The JPX, for those of you that know our product modeling nomenclature, which can be a little cryptic sometimes, If you see an X, here we have an L. If you see an X, that means they're accessible. And with the L, these are welded shut. So in industrial processes, there tend to be a varying amount of solids. The size of them vary, and control of what's coming into the separator can be difficult. So in the markets you guys are calling on, we really encourage the use of the JPX versus the JPL, only because it's extremely difficult if something were to get into the top of this to get it out. So just keep that in mind if you are quoting. If it's a budget-driven job and they're really being conscious about money, we have these available. I'll call it in your back pocket. But what you really want to focus on is the JPX series, this particular one. So, all right, hopefully that answers questions with the differences between the two series separators. We get that a lot still. So the other thing that we have that's kind of a nice tool are the PRX systems. And again, for those of you that have sold our products for a while, I'm sure you're familiar with them. And that includes either an eJPX or a JPX separator. We can do either one. The price list only shows for the JPX. So if you want to use an eJPX, just contact your inside salesperson or your regional manager, and we can get that pricing set up for you. But with the PRXs, we like to call it kind of a complete package, to where the owners and operators aren't having to worry about, what do I use on the purge? Can I put the separator up and purge it into a hopper or a drum? Where does that fluid go back to? So these are designed to be all-inclusive with the same flow ranges as that JPX separator. So again, if you want something kind of all-inclusive that is a turnkey, they just set it up in the field, then I would direct you to the PRX packages. And again, these are all with centrifugal separators, so we're still focused on material that sinks versus floats. And again, targeting that 44 to 74 and larger micron. All right, and then lastly, I'm crossing off my notes as we go through these two. So lastly, I'm not sure that a lot of our industrial folks know much about what we call a JCX or a JBX system. And these were designed to kind of tackle, I'll call it tanks or sumps, or again with process cooling, to where we would attach to a cooling tower basin. And so what we'll do, we'll open this up. So these are complete systems that come with a pump, a control panel, a separator, a way to purge the solids. And it's all packaged where all they do is they bring in single point power, and the purge valve, whichever it might be, is already pre-wired to that box. So this works really well for packaged cooling towers, especially if any of you guys are calling on industrial refrigeration, to where they're using ammonia condensers, typically like storage houses, cold storage, freezers, where again we talked about food processing. Maybe they're deep frying potato product, and then it gets stored in a freezer. Well, those freezers are typically cooled with ammonia condensers. And the bottom of those, which are just like a cooling tower, they end up looking like this. So it's kind of nice to be able to have a complete inclusive package that has your pump, your strainer, your separator, your purge device, and a motor starter to offer to them, to where they're not having to piecemeal these things together themselves. Again, the focus is on the settleable solids that are inside that basin. So I'm not sure how much this has been promoted to you as a rep, but it's a great package if you guys have above grade sumps that build up material over X amount of time that we can run through and remove that solid from a liquid with all one single package. So hopefully that's something semi-new that you guys had not seen before. And then one last one, again, for those of you that are that deal with municipal water supply, this is the only NSF, I'll call it larger device. It's an NSF 61 approved device that flow ranges from 225 up to a little over 2,000 GPM. And again, it's just a normal centrifugal separator. It's a non-accessible top, because mainly if you're pulling up well water, most of the time you're dealing with small rocks or sand and debris of that nature. You're not going to plug anything up to where you have to get access to the top. But I wanted to make sure that we at least pointed out that we do have an NSF 61 certified product. And a lot of times they want to change inlet rotation. They want to change, vertical versus low profile. That's okay. But as a whole, anything that we do, then it negates that NSF 61 approval. So if they need to deviate from this original design, then we can go ahead and create, for those of you, again, that have sold the product for years, we have what's known as a JSK, which has an internal Scotch coating, so 3M Scotch coat. That material inside is NSF 61 approved, so the water comes in contact with that versus the metal of the separator. So if we need to have custom or lower flows or higher flows than what you see here, we would end up going into the JSK models with that internal Scotch coating that is NSF 61 approved. So I'm not sure how many of you knew about that or not, but if you happen to do municipal water supply, that's a good product to keep in your back pocket also. So again, just to recap a little bit, we're trying to keep these to a half hour. Just we don't want to bore you guys to death just listening to one person talk all this time. So we talked about the solids, which are important. Do they float or do they sink? We've talked about 3-minute settling test with a mason jar or a water bottle like I showed you. Find out what we can and can't remove. If they want an all-inclusive package, then maybe we package bag filters and cartridge filters possibly together and pre-filter it with separators. But we're here to be able to provide the need that your owners have. So we're kind of doing these presentations to highlight the fact that we can do the stuff that floats and the stuff that settles. Because for so many years, we've only promoted really dealing with the material that sinks with our separators. So, all right, with that being said, then we'll call it an afternoon. Again, thank you for joining us. And if you do have follow-up questions, you can obviously speak with your regional manager or just call into the factory if you guys have something you want to discuss. Thanks for joining us, and you guys have a good afternoon. Bye-bye.